Afternoon, this is Mr. Hoopert speaking. I hope this is the afternoon because that means you got me for your math class in the afternoon, which means we're enjoying ourselves together. And we are doing Unit 6, Notes 1, Scientific Notation. Okay? You need to be able to write numbers and calculate in scientific notation. So we've done a little bit of this. Use to write numbers with many decimal places in a more condensed form. Use base 10 to indicate how many places are missing. So base 10 times 23. What you want to remember is like 6.7, 67 divided by 10 is actually 6.7. What happens when you multiply by 10 is you move the decimal place 1. So what they discovered is that it'd be easier to write really big numbers with this exponent. Now your calculator will also write things like this. Your calculator might give you an answer of e to the 23rd, right? That's their way of giving you scientific notation, all right? So this coefficient here, all right, this number has to be between 1 and 10, okay? Not even 1 and 10. 1 and 9, okay? Because if it's a 10, you're going to reduce it so that it's a 1, right? So if you get an answer of 60.22, you're going to remove this decimal to 60, and whatever it was, if it was 10 to the 22nd, then this number will be added 1, and it'll become a 23. So what we're worried about is, A, knowing how big this number is. You would move this decimal 23 times, and you would add all those zeros. Also knowing that the number out front, in front of the decimal, has to be between a 1 and 9, because there's only one number out front. Let me show you a few of these. Looking at this, so I see that we're going to have a 1 out front. This is where I want my decimal. Now, the decimal starts here and moves 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would say that this number is 1.329 times 10 to the 9th place. So, for example, this one, you could go to it and know that it's going to be 6.8. Right? Well, how many spots do I move the decimal? 1, 2, 3, 4, 5. Times 10 to the 5th. Now, 6.8 times 10 to the 5th is a number around like 68,000. Right? We don't want 680,000, I think it is. Now, you don't want that number. You want a really small number. So what they do is they tell you, hey, you're moving the decimal backwards. You're making it smaller. So they started putting negatives. So technically, some people will teach that you move to the left, it's a positive 9. If you move to the right, it's a negative 9. I use common sense. Meaning, if it's a really big number, it needs to be a positive 10 to the 9th. And if it's a really small number, it needs to be negative 10 to the negative 5th. So let's try another one. All right? I look at this right away. I'm going to put that decimal here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 again. Now look at this. 2 times 4, 5, 6, 7, 8, 9, 102 times 10 to the 9th. Alright? Technically, that's what it is. If it told you to round to like the thousands place, screen doesn't show up. Round to like the thousands place, I would have said 2.457 times 10 to the 9th. This is actually easy to read. These two, not so much. And then this last one, you should be able to look at that and know instantly it's 8.9 times 10 to the negative something. And then you would just come up here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I get negative 11. Alright? So really big numbers are going to be positive. Really small numbers are going to be negative. Just a rule of thumb. It's a lot easier to keep it straight. So now convert the following numbers to standard form. So what I would do is I grab a marker right away. 1, 2, 3. Then I need a 0, and another positive. So now I have one number there, and I need to move it 7. Well, if I have one number, I'm going to need 6 more zeros. Alright, so this would be 1, 2, 3, 4, 5. Yep, did this right. Alright, so that's 10 to the 7th. Now, the reason I wanted to get them out of the way is because here is our small numbers. So what this looks like is I would go take this, and I go 1, 2, 3. So I need 2 zeros, it looks like. So I would do decimal 0, 0, 4, 5, 6, 7. So this is the really small number they're talking about. Or in this one, I'd probably go 3, 6, 8, 7. So then I need 1, 2, 3, 4, 5, 6, 7, 8. And this is why we do scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8. I get it here though. So 0.0. Alright? So that's scientific notation. So it's supposed to make some things easier to look at, easier to read, and easier to work with. Now there's some rules of scientific notation. Adding and subtracting. These are like fractions almost. You can only add and subtract if they are the same power. Alright, so if exponents are the same, that's the only reason you can add the coefficients in front of the power. If exponents are different, you got to convert them to standard form. That means the big long decimal or the big long numbers, and then add or subtract. And convert answer back into scientific notation. So you should see if they're the same exponents, that's going to be nice and easy to work with. If not, you just got to go the long way around. Multiplying, you can just multiply the coefficients. The coefficients are the numbers in front of the decimal. You can just multiply the decimals together and then figure out how to add the exponents in the powers of 10. So like we did when we were multiplying monomials, you got to add exponents. And then dividing the powers of 10s, they're going to be the same thing. Subtracting the exponents is just like our monomials. Adjust the exponent as necessary. So, if you multiply 2.5 and 6.4 together and you get some answer like 17.8, alright, you need to change that 17.8 to be a 1.78. Alright, so if you get 17.8, adjust the exponent as necessary to make it a coefficient of 1, so then it would be 1.78. And when you do that, if this was times 10 to the 5th, it's going to be times 10 to the 6th. The exponent gets bigger if the number in front gets smaller. So let's do some examples. 0.37 times 10 to the 3rd plus 4.57 times 10 to the 3rd. First thing I see is these exponents are the same. Alright? So then when I see those exponents are the same, I'm just going to add straight across. It's going to be a 4.94 times 10 to the 3rd. There's nothing flashy about that one. Alright, 10 to the 3rd stay the same, and then 0.57 plus 0.37 is going to be 4.94. When I look at number 9, I don't even understand how we number these things. We did number 9. We're doing number 10. So 2.37 and 3.47. What I would do, so I would take a calculator. I would put them in the calculator. 2.37 times 3.47. I'm literally putting it in a calculator. So I get this thing, 8.2239 times 10 to the 7th. Alright? If you don't know how I got 7, you should see 4 and 3 right here. You add those together. Multiplying, you add those still. That's what we're expecting you to be able to put. So then I look at number 11. I'm going to type 9.6 divided by 1.6. You guys should know these zeros are irrelevant. I get 6. Now I also get times 10 to the third. So look at this. We have 7 and 4. 7 over 4, you are going to subtract the exponents and get that 3. Then last but not least, 12 is ones we don't like because we got to move this exponent. 1, 2, 3, 4. So 4, 8, 2, 0, 0, minus 1, 2, 3, 4, 5, 6. So it looks like 3, 4, 5, and then 4 zeros. When you do that, a lot of you will grab a calculator and do that. I don't blame you. I get negative 3401800. So what I would do is I'd probably move this in 1, 2, 3, 4, 5, 6. So it looks like it's going to be negative 3.4018 times 10 to the negative 6. A lot of kids struggle with these when they get to the quiz, so make sure you know there's going to be one of each of these, a multiplying, a adding, a subtracting, and a division. So you got to make sure that you know how to do these scientific notations. All right, let's do some more. 6 and 2.5. I happen to know that that's going to be 15 straight up. We're also going to times it by 10. 3 and 2 would be 5. Now you are going to get this marked wrong on a test. You want to take this 15 and make it a 1.5. So when you do that, 1.5 times 10 to the 6 is 5. You add 1 because you're moving the decimal place one more. This is the correct answer. Alright, so that's a point on your quiz. You have to recognize, hey, that coefficient was 15 out front. We got to change that to a 1.5. Otherwise, you're going to get that wrong. Next one, I do 7.8 divided by 1.2 in my calculator. I get 6.5 times 10. Now, 3 minus 4 is going to be to the negative 1. I think I'd leave it. Right, your coefficient is 6. Your times 10 to the negative 1. Now, technically, you could write 0.65, but we're just going to leave it. All right, we're not looking to confuse ourselves. 8.1 divided by 9 is going to give us 0.9 times 10. All right, now times 10, negative 2 minus 2 more is negative 4, so this is going to be times 10 to the negative 4. Now what we have to do is we actually have to move this back so that our coefficient is a positive 9. It'd be 9.0, but you don't have to write that if you don't want to. However, if this number needed to get bigger, that means we are taking a decimal place away, which means it's going to drop even smaller. So somehow you got to remember those rules of thumb. Now over here, what I would probably do is I'd probably go 6.48 times 10 to the 5th. When I do that, I left that the same, but in the denominator, I would have did 2.4 times 1.8 in a calculator. I would have got 4.32 times 10, and a positive 4 and a negative 2 is going to be a 2. So then what I would have did is I would have took 6.48 and divided it by 4.32 in a calculator. You get 1.5 times 10. And 5 here minus the 2 is going to be 3. So that's scientific notation. Alright, so that's all I got for you today. A couple different rules there for adding, subtracting, multiplying, dividing. It's the same rules as our exponents in Unit 3 and monomials, but you got to make sure you can keep them all straight. Thanks for listening today.